About a week ago, I saw a video by Tom Staten about an air-powered propeller. Not sure how practical the idea is, but I thought that it was neat. Anyways, it ended up not working very well for him, and I assumed that it was because all of his compressed air was leaking out right here. To me, sealing up a spinning joint without causing excessive friction seemed like a daunting task, and pressurizing a bottle with 60 psi didn't really interest me either. But I was really intrigued by the idea of compressed air being used to spin a propeller, and then using that propeller to create thrust. So I jumped into Fusion 360 and started drawing up a CO2 powered propeller. Now, I'm not entirely sure that this is more efficient than doing something like this, but it was a fun experiment anyways. So if someone could let me know with the laws of physics and what the difference is between using a gas to rotate an object to spin a propeller versus using a gas or a compressed gas to just directly propel, for example, a CO2 cylinder. It does seem that this is more effective, but I'm trying to understand why. If maybe my design for propeller blades, the fact that I didn't know how to design them is the reason that this didn't work very well, or if there are other factors at play here. I don't know. So let me know. So I'm going to go ahead and upload this design to Thingiverse. I'll put a link in the description, same with Tom Staten's video, and then I'm going to go through some instructions on how to assemble this thing if you want to make your own. Okay, so to build your own, you need a box of CO2 canisters, maybe 2. You need to print out the propeller, the cylinder holder, and the end cap that holds the cylinder holder in. It can't go through here. Next, you will need an O-ring that fits on the CO2 canister's seal. This one is a bit tight because it's slightly too small. Remember that your O-ring will be compressed by this seal inside here, so this will compress your O-ring a bit. So you don't need one that's tight on the throat of the cylinder. You need it to be able to hold on if you go like this, but that's all you need. Next, you need a sheetrock screw that is 35.5 millimeters long. So this O-ring should have an inside diameter of 7.3, an outside diameter of about 10 millimeters, and a thickness about 1.3 millimeters thick is the one I'm going to use. Okay, so I'm going to show you how to put this O-ring in here. Basically, you have to put it in here and get it all the way down in that hole, and since that's really hard to show you guys, I'm going to show you on this one that I printed out, and well, it kind of got botched. So you put the O-ring in there and then you push it down, and then you use a tool to push it down the rest of the way just until it's inside the groove. It has a little groove inside there if you look at it in your program, in your 3D printing slicer, and then the CO2 canister should be able to slide in there without pushing the O-ring out of the groove, and then it'll seal to that O-ring. And it'll stay in there too. So I've printed out 3 different versions of this. So the first version is a 3 millimeter hole from the CO2 canister to the end of each blade with a 2-layer thick wall. The second version I printed out was a 1 millimeter sized hole from the canister out to the end of the blade with a 2-layer thick wall as well. And then this version is a 1 millimeter hole again, with a 4-layer thick wall going with a 4-layer wall thickness. So this one should have less problems with air leaks, since when I made this channel smaller on this first design with the 1 millimeter hole, I could see it leaking air out all along here and along the edges of the blade, so I covered this one in silicone. I haven't tried it yet. This one I think should have less leakage even more because the extra walls added to the design. So I'm going to put the O-ring in this one. Alright, well I think that O-ring is seated in there correctly, so let's try this one out. This is a version with a 1mm hole and 4 layer wall thickness. So then you take your CO2 canister, you put it in there, screw the end cap on, and then, I forgot about this part, you need to insert this screw. So the sheetrock screw goes in the top. You want to make sure this goes in there straight. You also want to make sure that you don't pierce the canister. If your screw is longer than mine, or if your design somehow ended up shorter from your printer, the CO2 or the screw should not pierce the CO2 canister right away. And if your CO2 canister is really loose in there, which this one is, it's likely to be because you have some support material left up here where the screw goes in. So I have to take the screw back out. And I'm going to carve away the seal where the screw goes in. Basically, what I'm doing by carving out where this screw fits in is I'm making it so that when the CO2 canister is installed, the screw is tight to the seal. Because this unit here slides in and out. You can hit it with a hammer to punch the seal. You want the screw to already be resting up against the seal. You want the screw to be already resting up against the seal on the CO2 canister so that it doesn't have to travel very far to pierce it. Now, I would not suggest using a drill for this because the plastic is going to bite and the drill bit's going to go right in. Okay, now I've got the screw in there and the canister is tight. And there's a little tiny dent in the top of it. Now what I'm going to do is I'm going to take the screw back out just a little ways. And I'm going to apply just a little bit of silicone all the way around the head of the screw. Now, it would also be a good idea to seal up the exterior of this model because everything from here up is going to be under pressure when the CO2 canister is pierced. And it's really likely that some of the air is going to shoot out the sides of here and the sides of the blades here. So if you have some sort of a plastic that you can seal or smooth the outside of like ABS or some types of PLA, that would be a good idea. Okay, so now it's time to test it. You take the CO2 canister, put it in the canister holder, insert that into the rocket propeller, screw the end cap on, really tight. Make sure you do that, otherwise I'll show you. This is what happens when you don't thread the end cap on tight enough and try to hold on to it. And then you take a hammer or lineman's pliers and hit it. Of course, you're supposed to let go of it. And there you go. Hey, if you have any questions or suggestions for me, leave a comment below. And if you'd like to help my propellers reach a broader audience, then like this video and share it with your friends. Hey, thanks for watching.